Hello to this tutorial. We're going to explain how to use the calculator to do the lathe speed and the time required to do the cuts for different diameters. And it's actually I made an example here. I'm going to remove everything and start from the beginning. So in my example, I'm going to have I'm going to remove this one as well. Okay, so in my example, I'm going to do the following. I have a shaft. Let's say that this will be the envelope of the shaft. Let's make it as that's total envelope of the shaft, and the dark lines are going to be the two sections I'm going to have for this one. Total length, let's be 300 millimeters, and the actual diameter was 90 millimeters, and I would like to take this diameters two different sections. One of the sections is going to be 150 millimeter for the length and 80 millimeter for the diameters, and for the other one is going to be 75 millimeter diameter and 150 millimeter for the length. So I'm going to insert my original diameter for this cutting is going to be 90. Now by adding the 90, I saw that for the feed rate of 0.4 millimeter per minute, that's for the rough cutting, I started had the speed of the RPM for the high speed steel and the carbon insert. We're not going to use the ceramic to do the rough cutting. You only going to use it to do the finish cutting, as you can see here. So depth of cut for my first cut, let's say it's going to be 2 millimeters. You can see that the radius, the next radius is going to be 43. Of course this one should be equal to that multiplied by 2. Okay, I'm going to extend this one. Okay, now we said that we would like to have the final diameter for the first section to be 80. So I'm going to run this one for 300 millimeters. Okay, that's my first cut. I'm going to do the cut from here till here by having the depth of 2 millimeters. Now I would like to take it to 80, another 2 millimeters to be added. I got it as 82. Now I'm not going to remove 1 millimeter because actually 1 millimeter will be too much. 300. Okay, I got the time. Now you can see that the time became less. Now why? Because simply diameter became less. So the turning of the work part around the axis of rotation is going to be at higher speed, and this will make the cutting to become faster. Okay, now I'll try to make it more significant by having 1.75. Okay, to have this one as 82.5, then I'm going to remove 1 millimeter. Oh, maybe I can do it as 1 millimeter. So I got 80.5. Now why I left 0.5 millimeter? Because I'm going to remove the thickness of 0.25 by rough cutting. Now the next section I would like to have it to 75, so I'm going to remove 2 millimeters, another 1 millimeter. Now that's went too much, so I'm going to remove by 0.5, or I can make it as that's going to be much better if I'm going to do it 1.25 and another 1.25. Now each time you decrease the depth of cut, you are going to make your cutting tool live longer, as well as you are going to reduce the orthogonal forces during the cut operation, and this will make the less changes on the characteristics of the material you are cutting, and also you're going to increase the lifetime of your cutting tool. So the length in this case for this section is going to be just 150. We're not going to go all the way now. We're only going to remove the materials to this section. So 150 and another 150. Now once again, I still didn't start do the cutting for the ceramic insert. Now when I'm going to do the ceramic insert just for the finishing, I would like to change the value of 75 to 75.5 to 75. So what I have to remove is depth of cut of 0.25, and this will take it to 75, and this is the final diameter I would like to have here, and for this one is going to be 80. Now how am I going to remove that, and how much I have to move? Feed rate is going to be 0.25. My distance I have to pass is going to be the following. I will start from this center point, go up for the radius of this section, which is 37.5, because I don't want to go 37.75 because this will be higher than the depth of cut I would like to have. So just take it at 37.5, then 150. Then the difference between the radius, which is 75, and 80, which is 2.5, sorry, and this will make it 190, and then another 150, and this will make it to 330, right? 340, sorry. 340 is going to be the total length I'm going to pass during the finish cutting. Now by adding this value, I activated the ceramic insert, and I got the time for the ceramic insert during just the finishing. Now the time required for the high-speed steel to do the rough and the finishing is going to be just the sum of these values. Same thing for the carbide insert. For the ceramic insert, we're not going to have the full time. This cutting tool cannot do the whole operation of the rough and the finishing. So in this case, we are going to have two times. The first time is going to be by using the ceramic insert for the finishing and high-speed steel for the roughing earlier, and then I have to add these times for the roughing using the high-speed steel plus the time required to do the finishing with the ceramic insert. And for the ceramic insert plus the carbide, I'm going to add this time doing the rough cutting for the ceramic carbide insert for roughing operation, and the finishing done by the ceramic insert. So I have to add these times to get the total time to do the operation by using a combination of two cutting tools. Now the question is that if I'm going to go back to the original shape of this calculator, and I'm going to show you the example we have here by using the calculator used by your colleague. So I'm going to download that, and I'm going to open this file, and let's see what we're going to have. Okay. Now his calculator had stopped here because simply he didn't took it down to the next level. He chose that 10 is going to be the finishing. Okay, if we would like to use this one as a finishing process, so we have to do the following. First, we have to take this one to here, delete this one. I don't need these two, and I have to take this one to the next level. Okay, now this length is absolutely wrong. It's absolutely wrong, because what you have to do, once again, you have to add the radiuses and you have to add the length of the sections you are going to cut. Okay, and then you are going to do the same thing this time. No, that's wrong. Okay, delete, because I don't need to calculate further here, so I'm going to remove this one, and instead I'm going to have the sum of that. Okay, so this is the sum time. I can simply highlight it by yellow, and as we said earlier, for this one it should be a combination of the total time for the roughing with the high speed steel plus the time for the finishing with the ceramic insert, and vice versa. So the length, as I told you once again, this should be longer, and you have to notice that you are not going to have the 25 in this case. I don't remember the dimensions, but if these are your dimensions, this will be correct. Okay, so that's it for today. If you have any question, you can ask me during the lecture, or you can send me an email and I'm going to answer you accordingly. Thank you very much.